My name is Catherine Dean. I use the pronouns she, her, and I'm in the Backend program.
I'm Connie. My pronouns are she, her, and I'm in the Frontend program.
My name is Kelly Dinneen, she, her, from the Frontend program.
I'm Joe, he, him. I'm in the Backend program.
My name is Thao, she, her, and I am in the Frontend program.
As a former teacher, it is challenging to encourage, incentivize, and track students' reading progress in a fun and meaningful way. Therefore, we created BookWorm, a web application designed for young readers to track their reading progress. This app combines gamification and playfulness with the common task of a reading log that can be used inside and outside of a classroom.
When a user visits our application, they are greeted with a login screen. With a click of a button, a user can sign in using their Google account and is directed to a personalized homepage. On the homepage, the user will see the landscape of their reading journey. Across the screen below the header are options to add a new book to keep track of and to see their finished books. If we travel down the screen, we head into the soil where we can find the paths for each current book. The further up the reader is into each book, the worm travels up towards the surface.
Our visualization here is built with the D3 library, which allows us to dynamically append SVG elements to the DOM based on a dataset, and to define scales that govern specific relationships between quantities in the data and its visual representation.
If a user would like to add a book, they can click on the purple mountain that takes them to the form to search for the next book they plan to read. The form requires the title of the book and part of the author's name.
To access a plethora of books for users to choose from, we decided to consume the Google Books API. We then sent a book poro to the front end that contains only the information needed for our specific app.
The user can choose their book from the results, but before they can start a book, they must type in a prediction. Once a prediction is entered, the Submit button is enabled to click and their book will be then added to the list of current books.
On this page, the front end learned to be very deliberate about error handling, since there are at least 4 different error states that must be represented in the UI, depending on whether searched books are loaded, whether a request goes through, whether a student filled in the inputs correctly.
Once a user adds a book instance is stored in our database only if that book instance is not already stored. Then, a student book relationship instance is created to connect our users to their books.
Now when a user goes back to the home page, the submitted book will be added to the reading path. Under each path is a book link to view more details and add bookmarks. The user can click on the list of bookmarks to view their log for each book, including the date, the minutes read, notes, and an emoticon reaction. As the user progresses through each book, a bookmark can be added.
The progress data represented here is processed from a student's bookmark data, where a student logs the page number they most recently ended on. In future iterations of the project, we would hope to pepper the site with additional Easter eggs that combine play with feedback.
When a user clicks the Add a Bookmark button, a form is displayed to fill out the contents for a new bookmark. When all the fields are completed, the user can click Submit to add the newest bookmark to the list of bookmarks.
For both this form and the form students use to finish and review a book, the front end uses React Hook Forms, which takes care of controlling form inputs for us and limits unnecessary re-rendering when the form is incomplete. In future iterations, we plan to enhance the content of the prompts in the bookmarks, asking reflection questions tailored to different stages in a book, and even providing students with a virtual sketchpad so that they can submit a picture visualizing their learning.
The bookmarks table in the database has a one-to-many relationship with the student books joins table. This structure was challenging because the front end was not storing the student book ID, but instead was storing the student ID and the book ID. To prevent making multiple requests, we needed to include extra parameters to complete this query. We also utilized the FastJSON API include and relationship options to nest book objects in a query.
When a user finishes a book, the Finish Book button can be clicked, and the user is prompted to rate the book from 1 to 5 and write a review. In the future, we hope to display the review and rating for the finished book by implementing Web Push to broadcast the user's reading successes to their friends. For now, when the user clicks Submit, a celebration animation rendered with GSAP displays on the page, congratulating the user for finishing a book. Now, you see that the finished book is no longer shown on the path to make room for more books. We want to encourage the reader to not take on too many books by limiting the path to no more than 5. If a user would like to see all of their finished books, they can click on the yellow sand castle across from the purple mountain and view the books they've read and finished so far. Here, each book is displayed with a collection of their bookmarks.
This was an exercise in asynchronous JavaScript because the bookmark retrieval requires a loop of requests, one for each book.
Here is a list of the technologies that is used in this application. The front end focused on using React hooks, D3, and GSAP animations, and the back end focused on using Ruby on Rails and Postgres SQL database.
In future iterations, we hope to complete Friends network functionality, complete web push implementation, investigate and comply with applicable child safety privacy laws, have incentives and badges, add teachers, user story, and customizable avatars.